Hello everyone. In last lecture we talked about binary search tree. Now we will see C program demo for binary search tree. Now let's talk. So I have given here message as C program to construct a binary search tree. Now for this we need to include stdio.h and stdio.lib file. Lib file is because we are going to use exit function. Okay. Now the declaration of the tree node is similar to what we did in case of the linked list node. Here we have int value, that is nothing but the data part, and then bt node and left and bt node right, so that is nothing but left and right pointer. Okay, so left or right child in case of tree. Okay, so and we are creating the object of structure, that is root. Then we are create, and initially we are assigning value to root as null. Okay, then we are creating one more temp node, okay, which is also null. Okay, t2 and t1 we don't use them. Okay, for other functions we use them, that's why I have written it. Okay, now here I'm declaring some functions that I need, that is like void create, then void search, and to this search we are going to pass the root node, so that's why we need to have the parameter to it as the struct bt node star t, so it is nothing but the root node, right? So after create and search, we are going to search, we are going to display the element in order fashion, so we need to declare a function in order, and we are going to again pass address of the root node. Okay, so that's why I have written bt node star t, right? Now once this task is done, we have to do the insertion of the new node. Okay, so we are going to call in create itself, we are going in insert itself, we are going to call a function as create. Okay, so basically we want to do the insert operation, and in that we are going to call the create function. Okay, so I have declared one flag variable, but its purpose is different. Here I am not using it, so don't focus on the flag. I have used that flag for other purposes. Okay, that is what I haven't used in this program. Now let's create the main function, and here in main function I'm declaring one ch function, that is choice, and as I'm doing this program on DOSBox Turbo C3, I'm using CLR SCR to clear the previous background. Okay, now I'm going to ask user to print to please enter the choices. First I'm displaying this program is for a binary search tree BST. Okay, and I don't know where to stop, that's why I have given while 1. Okay, and then I'm going to write here printf backslash and enter your choice, and choices are 1 to do the insert, 2 to search or display, sorry, insert display, and third for stop, and that's it. So I'm going to ask the choice in a variable, that is ch, and then as we have to accept as we have to select one out of many, we know that we use the switch case for that. Okay, and here case values are 1, 2, 3 and default. So case 1 is what? Insert. So we will call a function insert. Insert function in turn should call the create function. Okay, so here I'm just calling the function, that is case 1, case 2. Case 2 is nothing but in order traversal. Okay, and here we are passing the address of the root node. Okay, or we are passing root node basically. Okay, and then case 3 is nothing but the stop, that is exit 0. Right, I'm also considering a default case. In this default case, if user is not giving the choices as 1, 2 or 3, then I'm giving message to the user that the choices are wrong, and then please enter the proper choices. Okay, that is 1, 2 and 3. All right, so once it is done, my program is over. Okay, so that is done, and then I'm writing get ch. Get ch is get character function. Okay, which will be used to display the black screen. We need not to write CLR SCR and get ch if we are doing this program in the online compilers. Okay, now to insert a node in the tree, I'm writing the insert function. So in insert function, I'm going to call the create function. This create function is going to create the node itself with the data part going to be accepted from the user. Okay, now initially we will check if root is having null value, that means the root will be the newly created node. Okay, so that is what the temp node, that is what we are going to create. Okay, and if the root is not null, that means we have some values at root, then we are going to call the search function again, and that is nothing but we are going to pass root to the search function. Okay, so that is nothing but the insert. Now we will talk about the create function. So in create function, or create function, that is function to create the node. This function is going to create the node. So first we are going to ask user to please enter the data. So data part is accepted from user and stored in the data part. Okay, then temp is nothing, that temp node we have already declared, and here we are going to assign memory to the temp node, that is by using malloc function. Okay, and after that temp data is nothing but, or temp value, we have declared value as a data element of the structure. So temp value is nothing but the data. Then temp left and temp right, both childs are absent, so here we will have null value to both. Okay, so null, that's it. So this is nothing but creating the node. So node is created. Okay, now after creating that node, the node is in temp, so we will now make our root is equal to temp. Now root is not empty, so we will search the root, so we need to go for the search function. Okay, so in search function we are going to pass the address of the root node. So we will see address of the root node, so wide search, so root node address is passed. Now we will check whether temp value is greater than t value. Temp value means what? The newly created node. Okay, and t value is nothing but the existing value node. Okay, so value is more than the root node, then what we are going to do, search t arrow left, so go to the left. So temp is nothing but value to search, and t is nothing but the root node value. So if root node value is greater than the value to search, value to search is greater than the root value, and also the root value right is null. That means whatever root node we have, its right pointer pointing to null, and whatever new value we want to insert is greater than the root. That means it should go to the right side of the tree, right? That's why we have called a function search t arrow right. Okay, now if that is false, that means temp value is greater than the root value, the new value is greater than the root value. However t of r is equal to null, that means now that value is empty, we don't have anything in that case. Okay, so that means we have to insert that value to the right side. So temp is going to become right node of the root. Okay, now if this is not true, that means the value to insert is less than, that is temp value is less than the root value, and also the left part or left pointer to the root is not null. That means we have some element to the left of the root. Okay, so in that case we are going to search to the next node, we are going to search the value of the next node, that is to the left. Okay, now in this case value is less than the root node. Okay, insert at the left. Now assuming that the t arrow left, that means the left pointer of the root node is null, that means that value should go, that means both conditions are true. So value is less than new value is less than the root value, as well as the root left is null. So in that case the root left pointer should contain the temp, that is newly created node. Okay, so that's it. So now we are going to do the recursive function call to perform the in order traversal. So in order traversal, okay, we are going to again pass the value of the root node. Okay, and then if root node is null, that means we don't have any element in the tree, right? Now else, if it is not the case, then we will check whether root node left is not equal to null. So if it is not equal to null, that means we have to do in order traversal to the left side. And if t of so that element is printed. Okay, and if t of right is not equal to null, in that case we have to do the in order traversal to the right side. Okay, and that's it. Okay, so that is nothing but end of the program. Now we will run it. So control F9, everything is okay. So it is asking me to choice as one insert, two display, and three stop. So I'm giving choice as one insert. I'm inserting data as 100. Okay, again I'm giving choice 1 and data is 75. Again I'm giving choice as 1 and value as 95. That should go to the right side of the 100, right? Then I'm again giving choice as, let's say, 1 and I'm inserting let's say 50. That should go to the left side of the 75. Right side of the 75. 95 should go to the right side of the 75, and as 95 is less than 100, all 75, 95 and 50 will be to the left side of the 100. And then one more element I'm going to insert. That element is 110, which is greater than 100, so it should go to the right side of the 100. Okay, and now I'm going to display the element. So when I'm going to display element in order, that means I'm going to get increasing order element. So 50, 75, 95, 100 and 110. And now I'm giving choice as 3 to stop the program. Okay, so program is modified, that's why I'm saying yes. Okay, so I hope the program for binary search tree in C is clear to everyone. Okay, try to write this program and also try to implement try to modify this same program for execution of the post order and pre-order traversals. Okay, so thank you.